Hi, how's everybody doing today? My name is Noah Gift, and I'm excited to talk today about some of these topics because they're going to address, I think, some emerging things that I'm working at Duke, some of the things that are happening in our industry, and also it's going to be fun to talk about the fact that I've been with PyCon, I guess, almost 20 years. I think the first talk I gave was I feel like I'm getting pretty old. It was almost 20 years ago. First, let me talk a little bit about my background to just set some stage for the other things I want to talk about. So I started off working in the TV and film industry in Hollywood. My dad had a television production company, so a lot of coders today, were working at, for example, their dad's software company. I just happened to work in TV and film, and it was a really good experience for me to understand the rapid evolution of an industry. And when I was 18, I was working for ABC Network News as an editor, and I was editing live news and patching it in, and it was such a kind of aha moment, like, wow, this is all this technology is really driving our lives. And then as I got more involved in the film industry later in my career, I realized that things had gone digital. They'd gone analog to digital. So I'll get back to that in a second. And then I worked at Caltech from 2000 to 2003, and that's actually when I first learned Python. A kind of a funny story was that I was playing ultimate frisbee at lunch, and Titus Brown, who's also a big Python person, was always talking about Python after we would play an ultimate frisbee game, and I felt like there was peer pressure, like I better learn this Python or people aren't going to like me at Caltech. So that's how I kind of got started with Python, and that was a good period in time, about 2003, where all the analog had shifted to digital. And so I thought, you know what, I'm going to go back into TV and film here. And I had a pretty good run where for about 10 years or so, I worked on what I would call data engineering. So from that period of time, like 2003 to 2013, I worked on the movie Avatar, did pipelines in Python, worked on Sony ImageWorks pipelines for their animated movies, Disney Feature Animation. So in many ways, I think the data engineering with Python really started in the TV and film industry, and that was one of the innovators. And then later, I did my tour of duty in San Francisco, spent 10 years there, worked at startups. The last job I had, I built a sports social network, and we had a shot at greatness. Like a lot of startups, didn't work out. And then recently, from about let's say 2016 to current, I've been teaching at universities, teaching at Duke in particular. I'm executive in residence and part-time professor, and so I teach large language models, MLOps, data engineering, cloud computing, and I also had a personal goal for myself where I wanted to write 10 books. I wrote 10 books. I'm never writing a technical book again. I'm done. But I've also been working on Coursera next. And so the stuff that I've focused on the last few years is building about a master's degree worth of content that I currently have produced. So that was a fun experience to, in a way, like design what I think an AI master's would be. And I'm still going. I still got a little bit more time under my belt. So that's the background here. Let's talk a little bit about MLOps, something I'm very passionate about. So MLOps, I think, is an interesting topic because it means so many things to so many different people. But what I think is interesting about MLOps is that there's this rule of 25. And so 25% of it is going to be DevOps. 25% of it is going to be data. 25% of it is going to be your models. And then 25% is business. And you can't extract one of those things and put it away and just say, well, I like the models, or I like the DevOps, or I like the data, or I like the business. You have to have all four components to practice MLOps. I think a good example with the business side is it would be easy to say, oh, look, look at these models, they're perfect, but if your company is not making revenue, it doesn't matter. Like if you solve the wrong problem, it doesn't matter. And I think that a lot of times people get confused about MLOps and that they don't realize that DevOps is a requirement. If you don't have DevOps, you cannot do MLOps. So if you don't have continuous integration, testing, formatting, you have a notebook somewhere that's in somebody's repo. That's not MLOps. I don't know what else that is. That's something else, but that's not MLOps. You have to have automation. You have to have automated testing. And I think in particular, notebooks, I think a lot of people have talked about this, are not production software. It's not the use case for a notebook. Now, again, I've been in Python for a long time, a huge fan of Python, but I also think it's important to say this is what Python's good at. This is what Python has competing technologies against. And in particular, I would say lack of binary deployments for production software really isn't a great fit for models, because a model, if it's a 10 gigabyte model, for example, could fit pretty well in a binary deployment story. You statically link the model into the binary, you give it to somebody, you're done. Also, the CPU and memory is something that wasn't a design feature of Python. Uh, for example, with memory, in some cases, and I'll talk about this later, you can get 70 times better energy efficiency with other languages than Python. Also, concurrency. We know for years and decades people talked about concurrency. That isn't really the strength. And I would say this is another one that I don't know how many people have talked about enough, but this, I would call it the virtual environment productivity tax, which it really is a tax. So if you have a hosted environment, I think Python is beautiful. Like if you have a Colab notebook or SageMaker or something, but the fact that you have to constantly be iterating over here isn't in my opinion, a great pattern for production software. And then also modern languages, right? There's modern techniques with security, typing, and then finally packaging. I think the big issue, if I have, well, first of all, I have no influence on how Python is developed, but I would say there should be one and only one way to do packaging. And it should come from the vendor of the language. Multiple competing solutions, I think, is ultimately wasn't a great strategy, in my opinion. So let's talk about Rust a little bit. Some of the benefits of Rust: binary deployment, you get it for free. So by default, you actually do cargo run, you get a binary. The performance of Rust is just exceptional. It's as good as it gets. And then if we also talk about safe concurrency, so because of the way that the compiler was built in Rust, concurrency is actually one of the safest ways that you can do concurrency of any language. Because of the borrowing and the ownership model, you automatically have these great patterns. And the libraries built, like for example, Rayon, really give that for you. And then in terms of security as well, it's a modern language that was designed for security. And I think this is a topic that isn't talked about enough, which is that we do care about security. And security is a critical issue, and it's something we should be talking about. And then finally, even though it's an emerging language and some of the things that it's doing are still behind Python, I think MLOps, LLMOps, and data engineering libraries are exceptional. And I'll talk about a little bit of those in a second. So if you're a Python programmer, I just want to talk about some of the key components. And I think as someone who's been in Python for a long time, it's easy to get tribal and say, I only do Python, or I only do Rust, but it's almost like saying, I only eat rosemary. Well, rosemary is amazing. Rosemary is good with chicken. It's good with potatoes, right? It's the combination sometimes that can make the great meal. And in particular with Rust here, you see that there's a general structure that you get when you create a Rust project. And I think this is something that would be amazing if in the future world of Python, if there was a default tool that could include a general project structure. And I would even say that the directory structure of Rust could potentially be a replacement for Python virtual environments if the language itself installed a packaging solution that was directory based. I think it could be interesting. But I think that's one of the strengths of Rust, is that you get this automatic creation, you get binaries created automatically, project dependencies automatically, and then you get the type and memory safety. And then if you are building for command line interface, for example, I think that's really where Rust has a strength. And in many ways, I wouldn't say this is a competition with Python. It's just a synergy, right? There's a lot of stuff that I'll talk about that Python is exceptional at. Now, let's get to the real problem for a Python programmer, which I'm very sympathetic to. The reason I started programming in Python is that it's beautiful, right? I mean, that's the thing about Python. It's easy to look at. You can think in Python. Like I could have dreams sometimes where I'm just thinking about different language features of Python. Rust is not like that. Rust is ugly, and it actually is like eating your vegetables. Like it is a very awful language to look at when you first start, building it. The syntax is going to be harder. The compiler is just really mean. It's like a bully. It's just constantly like telling you things like, "Hey, what is this? Why are you picking on me? This is really hard." But I think two things that are game changers to me is the one I talked about before, which is the cargo ecosystem. Really is stunningly good, and that's one of the ways that I would say it gets rid of the productivity tax of the Python virtual environment, where it's like, ooh, even if there was no other tools available, the fact that I don't have to say virtual env source, deactivate all this back and forth, or use some other competing tool is amazing. And I think generative AI, it is actually a little bit overpiped, but it is an amazing technology. And for a language like Rust, where the compiler is super mean, hallucinations actually are not as big of a deal with a language like Python, where they are a big deal, right? Because you can have runtime errors. So let's talk a little bit about generative AI. There's a lot of different analogies for generative AI, but I'm going to use the one that I think is a pretty good one, which is like a trampoline for your code. So when I was a teenager, I remember one of my friends had a trampoline, and I was at one point in time trying to do a backflip, and I just could never do it. I just could never do a backflip, and I tried going to the ocean and like, doing a backflip in the ocean. I still was like, I'm too scared. I'm going to hurt myself. And then I went over to the house and they had a trampoline, and I tried it, and I was like, wow, you can actually do a backflip. So it was the acceleration of the tool that let me understand the form, and also I would say get afraid of like seriously hurting myself. That was the real part of the backflip that I was scared about. It was like, whoa, I really don't want to hurt myself, and so it let me come over the fear of doing this technique that is a little bit dangerous. So I think that's really what generative AI does with a language like Rust. Now, I also want to talk a little bit about something that I experienced as a professor. So I've taught thousands of students to program, and the one that always, I guess, makes my irritation, come up a little bit is this concept of, what do we actually care about? Like what's useful and like what's useless suffering. And really, at the end of the day, and this is why Python is such a great language, is that it takes logic and it simplifies it in a way that is maybe the simplest possible way you could express an idea in Python. But the problem is that a lot of time when you're teaching a new student about Python, they're not even focusing on the essentials. They're focusing on useless suffering, suffering where there is no gain. You're just irritable. You think that this is the journey that's going to really give you some kind of advantage. So I would say like runtime errors, packaging systems, um, boilerplate code, logic errors, virtual environments, setting up your development environment is useless suffering, because all of these things are going to be constantly changing with new techniques. And then the other one to be aware of is we have some optional but useful suffering. And so object-oriented programming, that's another beautiful thing about Python. In fact, I would say it's a huge strength, is it's optional. You don't have to do object-oriented programming. A lot of times new programmers, the first thing they do is someone teaches them about classes, and then they start doing multiple inheritance, and then they say like, look, I can't program, I'm a bad programmer. No, you're doing optional suffering that you may need it, you may not need it, but you need to focus on the essentials. So that's my way of saying that generative AI can really harness a lot of the suffering so that it's useful. Now, that's the positive. Now, let me tell you what I think is some of the negative. So I don't know why I'm the only one who's skeptical here of what's been happening in the startup industry, but I like to call it the Ponzi as a service. So you have in the world of Gen AI, you make stuff, we'll just take it. And then in terms of the tech startups, we have all these people who are saving the world. It is kind of strange, isn't it? Is there anybody that has been convicted lately of fraud that wasn't saving the world? It seems like there's a pattern there. And then we also have crypto, which I think a lot of people are very skeptical of crypto because every time someone does a Super Bowl commercial, there's some kind of bad problem that occurs, and people lose their life savings. So I think if you're saying that you're going to replace money and you have this amount of criminal action, there's something going on there. And then also, if you look at the negative externalities, which I think is not really talked about enough with startups, is that just because you created something like a nuclear power plant and you got the benefit from it and maybe the people in your town got the benefit, if you take that nuclear waste and dump it down the river, that's a negative externality, right? Other people are getting that nuclear waste and they're not getting any benefit. I think that's gambling, for example. Is that useful? We don't know, right? And then if you look at some of the other things here, there's a lot of synchronization with universities. That's something I see a lot. We also see that maybe some startups change the ownership equity kind of on the fly. And then the big one, and then they push the risk as well to the employees, but the VCs have a portfolio and they have no risk, or essentially no risk. But the big one, and this is the one I would tell a lot of people to look into, is the concept of regulatory entrepreneurship. So regulatory entrepreneurship, if you just Google it, there's a pretty big paper on it. It's basically, let's break the law on purpose to make money, then let's go lobby people in Congress to change the laws, and then that's my company. So I think what we're seeing with generative AI is the same pattern, right? With Uber, with Airbnb, et cetera. It doesn't mean that these tech startups don't do some good in the world, but I think we have enough historical data. A lot of us are data scientists. Let's look at the signal coming from the data, and let's act on the signal, which is we should exercise caution, especially if someone says, I'm building AGI, I'm helping humanity. I think we need to be very careful about all this. So this is what I tell students a lot, is when I mention, hey, we should be careful about which tools we should pick for generative AI, a lot of students will say, oh, everything's bad. All companies are bad. Or if you talk about some kind of political issue, all politicians are bad. It's like, that's a very weak ethical argument, right? Is that no, we can weigh things, right? This is in fact one of the foundational images of justice is we have scales, right, where you weigh things. So all things are not equal, right? The other thing is that when you're looking at different technologies, you should look at multiple. Now, I'm not saying this is what you should do. This is the one I look at is, what is the corporate structure? Is it a public benefit company? Well, okay, maybe I should believe them more if they're going to solve, some huge issue for humanity. Wait, you're a for-profit company and it's all closed source? Well, maybe. Also, the leaders. What have the leaders done before? If you've practiced regulatory entrepreneurship for decades, now you're not going to practice regulatory entrepreneurship. So I think this is the caution I think that people need to look at. So let's talk now about the positives here a little bit. Is that my workflow for Rust, and this was really the light bulb that went off, was that, hey, I want to find the meanest language that bullies me the most and tells me I'm a bad software engineer. And so I found Rust when I want to do generative AI. And so the workflow that I typically do is I do a cargo project structure first. I'll have the different components. I am a fan of the makefile concept. I do the same thing in Python, where you have this process of building, formatting, linting, testing your code. What's interesting about generative AI, because it's really designed for a feedback loop, is that when you get a suggestion from generative AI, my opinion is you should format immediately, because just by slightly changing and this is, I would say, with Python or Rust, you're gonna slightly change the suggestion and you're improving your code. The same with linting. Again, with Python or Rust, why would you not lint your code after you've actually got a feedback from the generative AI? Then I also will use either a different technology like Claude or the AWS Code Whisperer to actually just add another signal. So I think if you have a very good structure for your project, you get the most benefits out of generative AI. So let's talk a little bit about Python though, because this is a Python conference, and let's talk about the stuff that is amazing about Python. So, and again, as teaching students, these are the things that I see quite a bit where students are really have gotten the message that Python is a great language, is that the data science libraries are impressive, right? There really isn't a competing solution with the depth of the data science libraries in Python. For prototyping, it's impossible to prototype quicker than a language like Python. Again, you can think in code, right? You can have an idea and it just comes out of your fingertips. In fact, in many ways, is generative AI even helping you if you're an expert on Python because the syntax of Python is so good? Also, the deep learning libraries, PyTorch, TensorFlow are amazing. And then these are the ones I think that are not talked about enough is teaching and API documentation. We're blessed in that pretty much any API anywhere, you're going to come across a Python API documentation. So if you want to learn something, everybody should learn Python, even if you don't like Python and you want to program in C# or something like that. The API documentation is so amazing. And then for teaching, I've heard lots of different competing topics about teaching, but I think Python is amazing for teaching because, again, you're eliminating the useless suffering and you're focusing on the logic. Now, let's talk a little bit about those success. What if you look at exponential growth does by definition cannot always be exponential. So now we're at a point now where, this is more of a question, is are there any language features that are going to increase adoption? Or another way to put it is 30 years of success with Python is amazing. I mean, it's the top language in the world. I mean, why isn't the best good enough, right? I mean, this is an amazing journey that I was a little bit a part of. So, but there's some problems, right? With should we have true threads, the performance, a little bit, the packaging. So I think it's more of celebrating the success of Python versus maybe trying to reinvent it and make it a new language. And so I would say it's a good question with any data scientist is when is the peak? When is the peak about? And the peak could be everybody in the world that's a programmer knows it. I would say that's a very amazing journey for Python. But what I think would be like a supercharged tool would be to add a little bit of Rust with your Python as well. So let's talk a little bit about mixing Python and Rust here. And this is a pattern. I am obsessed with the command line. I've been obsessed with the command line for almost 25 years. And I think this is a very cool story for Python, which is that you could write computationally expensive code in Rust very easily with PyO3 bindings, link in the .so, and then the library that I like, because I like fancy libraries, is Python Fire. You don't even have to write any code. You can essentially slurp in the Rust code and automatically create a command line tool. I think this is as good as it gets, in my opinion, of like, if you're obsessed with Python, you love Python, but you want to just kind of add some secret sauce to it, I think this is an amazing technique. Now, the other thing we're seeing as well with Python is it's unavoidable. You're going to be using Rust tools in Python. In fact, the obvious one to start off with is the linting. Why would you wait for 60 seconds to lint your code if it could be linted sub-second? And that's what we're seeing with tools like Rough, which is just an amazingly fast linter. The other thing too is that if you're bound not just by CPU, but if you're bound by memory, which is something you're bound with things like AWS Lambda, that's where I think Rust also comes into play, and we see that with things like polars. Okay, so let's talk a little bit about MLOps here next, which is the area where I spend the majority of my time. So if you're interested in large language model and putting those models into use, my opinion, Rust is actually the best solution for that. And here's like a really good example is if you wanted to make this ridiculously fast but cheap AWS Lambda and maybe call it in Python, right? You have a command line tool that invokes it. This would be a really cool pattern is you would use something like polars. You would get, millisecond response. You could even target the ARM environment to save money. And so it again, it's almost like putting that .so file inside of your PyO3 command line tool is you could slurp in this particular feature. Now, let's talk a little bit as well about in LLMOps that I think it's important to think about a cloud-based development environment. Now, there's a lot of stuff going on this slide, and I'll share it with you later, but the advantage for large language models is I think maybe a lot of you have probably tried to run a large language model. Well, if you don't have an NVIDIA GPU, have fun, right? So this is where the GPU-enabled workflow becomes very amazing. And what we're seeing as well is that we're seeing an emergence not just of the notebook-based workflow with GPUs, but we're also seeing editors. And I think this is an emerging thing that we haven't totally seen yet, is why don't I have a cloud-based uh, editor that is actually has GPU enabled with it? We see only the notebook. Now, one of the things that I'm focused on here with the students at Duke, and actually Duke is going to become more and more involved with this, is actually, I would say, almost creating a solution that was like the old days of Linux and Windows, where why would you use Linux? I mean, I actually like Windows Server, by the way. I like IAS, I like C Sharp. I also like Linux more. And I like that there's a solution that's available. What I see with large language models is that with tools like Rust Candle, if you haven't tried it, it's shockingly good, is that once you've done a compilation and you target a GPU, you get a binary, you're done. All you have to do is do dot slash dot, binary dash dash prompt, and you can start running, open source competitors to OpenAI. You can run your own coding assistants. All of these are actually available because of the inherent features of Rust. So one of the things that I'm working with Duke students on is actually figuring out a way to evangelize every single recipe that you would ever need. How do I set up a build system? How do I do ethical sourcing of data? How do we do the build system on all cloud platforms? And eventually, one of the things that we're also thinking about is, could we even do like the old days of Linux, where if you remember how Linux first was distributed, there's a .so, there's an ISO file, and there was mirrors at public universities. Can you imagine if, in fact, there's just binaries that are available that have there maybe a binary that statically links in the model, and you could say for grandpa, grandma, hey, here we go. Here's your own open source tool. And I would say that related to this is what I see happening that kind of ties everything together, is that in perfect competition, all profit leads to zero. And that's why the operating system uh, industry, there was proprietary operating systems. I've used the mainframes, IBM, HPUX, Solaris, etc. But what happened was, in perfect competition, all the profit diminished. So I think we're also going to see this with, right now, you see that there's proprietary operating systems. But one of the things about the hype cycle that I would ask everybody to really pay attention to is, why is it that you're trying to do attempted regulatory capture right now? Like, we just got started with large language models, and people are going to Congress and saying we need a license it's like saying I need a license for linear regression. Like, this is the most ridiculous thing I've ever heard. And then if you look, though, what it could be is that there is no advantage. There's nothing. Everybody can do linear regression. Everybody can do k-means clustering. So eventually, this is what I think is going to happen, and I want to be part of it, is I want to reduce all profit to zero. Doesn't mean that people aren't going to make profit as training and services, integrations, etc. So how could we do this? One of the ways that we could do this is by accelerating the Gen AI profit to zero approach. And so, we could, in this, again, I'm personally doing this, and I'm doing this with Duke University as well, is I want to create as many example recipes, like reverse engineer every single thing you need to do for large language models. Also, not having specialized services or vendor necessary at all. Not that vendors aren't great. Hey, it's in competition, you want all kinds of solutions, but ultimately, I think having solutions that have no vendors specifically baked into them are an advantage. And then I think this is the big one too, that I'm kind of shocked at us tech people for not really diving into more, is this idea that, like, because I took it, it means that it's okay. Like, it's a very strange, mentality, which is, well, yeah, we found these pirated data sets on the internet, and somebody else broke the law, so it's okay. Well, no, it's not okay. It's not okay to pirate people's data. That's disrespectful. In fact, you need to actually have people's consents. So I think ethically sourced data could be a huge competitive advantage. In fact, is that I think a lot of people are like, hey, anything you do in tech is okay as long as it works. But uh, the end result of that is that you could compete on saying, look, we're going to ethically handle sourcing data, and that's how we're going to compete against you. And then also having, like, the mentality of free and open source software, and actually have nonprofits libraries, universities actually help with this. And I would say I'll leave on this, and I don't know if we have time for questions or not. I'm here. You can ask me afterwards. But I mean, imagine the dystopian world where, when I was a kid, I would go to the library every single week, and I would get books, and I would read books, and that was my source of information. I mean, can you imagine having a world where you actually have to call somebody's chatbot that's proprietary, that somebody owns, and that's all source of information? That's a very scary and disturbing world. So hopefully, I think enough people go, look, we actually can do these things ourselves. We don't need, not that all people that are doing proprietary technology are bad people, but that I don't see the future being a great future if there's a chatbot that somebody controls, and that's how all information is propagated throughout humanity. I think that's that's not a good strategy, and we can all be part of the solution. So that's it for my talk. I also have a bunch of links here. So even though I did a lot of like jabbering and pontificating, this is all code, all hard code, hundreds and hundreds of recipes on like Candle Cookbook, Rust MLOps, also Python. I have my opinions for Python for MLOps, data engineering, Lambda, etc. All right. I don't know. Yeah, I don't know. Do we have any time for questions, or we're good? Okay. Thank you so much.